photography is more of an art than a science. However, film photography should be considered more of a science than an art. This is because of all the steps that it takes to take the picture, develop the picture, and eventually see the picture. Now, to understand the chemistry behind taking a film photograph, we must understand the history. The camera obscura was the first known object to so-called take a picture. It would be a lens in a wall or a box, and it would project light image through the lens onto a wall or a sheet. This picture would be inverted and upside down because of the nature of the lens, and people could not figure out how to save the image until Joseph Nicephore Niepce came around. He was the first person to record from a camera obscura. He coated a plate in bitumen, and he left it in his camera obscura for over 8 hours. You can see the picture here. Due to the long exposure time of 8 hours, the shadows are very goofy, and so are the highlights, and you can't really tell what's going on. But this is the courtyard behind his house. Then photography became more commercial. Daguerre created something known as the daguerreotype. He did this by using a copper plate. He would coat it in silver, and then he would expose it to iodine vapor. This process was much quicker than the camera obscura used by Niepce, and it was only 8 minutes compared to 8 hours to develop a photo. From here, over the years, it became more and more streamlined and more efficient. George Eastman was the first person to create the film photograph, known as the Kodak. This box on the screen is the first film camera. He used film instead of plates, and the film would be coated with a silver halide compound. Now this takes us into the chemistry of the film photograph. Some of the most common is using a silver halide compound to be able to develop and capture photos. This is done by the oxidation of chlorine and of a silver chloride compound on the film. When it's exposed to the light energy through the lens, the light energy pulls the electron off of the chlorine, and then the silver reduces to produce the silver metal. The silver metal is what stays on the film, and from here you get a negative. And the process to develop the film into a positive that you can see and you can print is relatively similar. Another form of film photography is the cyanotype. By Navarrete really helps understand how the light interacts with the compounds. So here it is.
In case, my setup was now ready to go, so I put it outside in the sun. I exposed it for a total of about 11 minutes, and the color slowly changed to a light brown. What was going on here was the UV catalyzed degradation of the ferric ammonium citrate. It was normally made from iron 3+, but the UV triggered a photochemical reaction where the citrate donated electrons to the iron and reduced it to iron 2+. Because it was UV catalyzed, the reaction occurred most prominently in the transparent parts of the negative, but it was mostly blocked in the areas that were darker. On the other hand, the other component, potassium ferrocyanide, didn't react with the UV, and it kind of just sat there. It becomes very important in the next step, though, and you'll see.
Nile Red has that whole video is very good at explaining the chemistry behind developing pictures, as he goes into great depth with the exposure time and how the UV light affects the paper. So overall, film photography and other types of photography, such as the cyanotype, where you have to develop the pictures using light and other chemicals, I believe is more of a science/chemistry than art. Thank you.